Hello and welcome. In this lesson, we'll go over optimizing 2D shapes. To start with, what is the meaning of the word optimize? Whenever we're trying to optimize a quantity, it means that we're trying to find the best value of the quantity. Now, let's take an example of revenue. Whenever we are trying to analyze revenue, we're going to say that the best value for a revenue would be a maximum value, because maximum revenue can produce maximum profit. So to optimize the revenue means to find the maximum value of it. However, when we talk about costs, on the other hand, most of the time we try to find the minimum value of the cost, because minimum cost will provide maximum profit. So to optimize the cost means to find the minimum or its minimum. So the optimum value of revenue is a maximum, and the optimum value of cost is a minimum. So to optimize then means to either find the maximum or the minimum value of a quantity. Now we're going to take a look at 2D shapes today, and we'll talk about the two measurements that we focus mostly on when we analyze 2D shapes, and they are perimeter and area. So we are going to look at the connection between perimeter and area, and we'll try to find what is the maximum area if the perimeter is fixed, a fixed value, or we'll try to find the minimum perimeter if the area is fixed. And this is kind of a problem, easy to understand the reason why we discuss it. If we look at it this way, oftentimes in everyday life, we may be given the task of enclosing a certain area, but we have a fixed amount of fencing, okay? So we want to enclose the maximum area. So we need to know the connection between the shape that would give, for a fixed perimeter, that would give the maximum area. Similar to this, sometimes we need to enclose a certain area, but we don't want to buy a lot of fencing, so we want to minimize the cost of it. That's why, because that buying the fence costs money, right? So we need to find the minimum value of it. Now, this is not a new problem for you, because it's something that we have discussed earlier in grade 9. So we're going to go over and summarize all the findings from grade 9. So first, if we're given a fixed perimeter, the largest area rectangle with all 4 sides enclosed will be in the shape of a square. Which means that it will be a rectangle where length and width are equal. Now, oftentimes we'll be given the task of enclosing a rectangular shape area, but we won't need to use fencing on all 3 or 4 sides of it. So we only need fencing on 3 sides of it. Say, for example, there is an area where there is a river maybe, and we are trying to enclose a rectangular shape area, so we won't need fencing on the side where the river is located, but we're going to need fencing for the other 3 sides. In this case, the largest area will be ensured when the length and the width are connected to each other by the equation length equals twice the width. Now, the third scenario is the largest area rectangle when we have only 2 sides enclosed. So, for example, if we are trying to enclose the parking lot of a certain building, and the building is, let's say, an L-shaped building, and we're not going to need a fence all over 4 sides, but we're only going to need to fence 2 of the sides. So in this case, the largest possible area will happen when the length and the width are equal, which means that the rectangle must be in the shape of a square. Okay, now when it comes to triangular shapes, we're going to say that the largest area rectangle will be in the shape of an equilateral triangle. So far, and I want to emphasize this, if you look at all these definitions, then we're going to say that the largest area with fixed perimeter will be when there is symmetry in the shape that you are enclosing. So the higher the symmetry of the shape, the greater the area that you can enclose. So in this triangle, we need to have all three sides equal. Now let's take a look at a couple of examples where we can practice all these definitions together, okay? So in the first example, we have what are the dimensions of a rectangle with perimeter 20 meters and maximum area? And what is the maximum area? So what we are given in this case is the perimeter, which is fixed 20 meters. Now we want to find the area, and not just any area, but the maximum area. And we want to know what are the dimensions, or what dimensions will give the maximum area. Now because the area enclosed will be in the shape of a rectangle, and it's enclosed in all four sides, otherwise it would have specified it. So we're going to say that the largest area rectangle must be in the shape of a square, which means that length and width must be equal, which means that the perimeter must equal, excuse me, 4 times length, or 4 times W, or you can call it X if you wish, doesn't really matter. So since the perimeter is 20 meters equals 4W, that will make W equal to 20 over 4, or W equals 5 meters. Okay, so we're going to say that the dimensions will be length equals 5 meters and width equals 5 meters, obviously, or length equals width equals 5 meters. So we also have to answer the question, what is the maximum area? So the maximum area of a square would be length squared, and with a length of 5 meters, so that would be 25. So we'll say that area equals 25 meter squared. Now let's take a look at the next example. As the owner of a road painting company, you are given a contract to paint the outline of a rectangular parking lot at the back corner of a building. So here is the building, the back corner of it, and we are trying to enclose a rectangular parking lot. The building is to border 2 of the 4 sides of the parking lot. So we're going to need to enclose only this side here and this side here. You have enough paint for 45 meters, and you must use all the paint. So what are the dimensions of the parking lot with the largest possible area? So the information given here is that we are given enough paint for 45 meters, which means that W plus length together must be equal to 45. Now the question is, what is the maximum possible area? We know that maximum possible area of a rectangle with only 2 sides, so with 2 enclosed sides, is in the shape of a square, which means that we're going to want length to equal W, which means that The perimeter W plus length equals 45 is the same as if saying W plus W equals 45. So 2W is 45, or W is 45 over 2, or 22.5. So length of 22.5 and width of 22.5 means that the area would be 22.5 times 22.5, or 22.5 squared. So area equals 22.5 to the power of 2, which is 506.25 meters squared. This is the maximum possible area that we can enclose. Okay, now we're going to move on to the next topic. So if we are given a fixed area, what would be the shape of a rectangle with a minimum perimeter? Now this will be very easy for us to remember because there is a connection between maximum area and minimum perimeter. So whenever the maximum area happens, then we have the minimum perimeter as well. So the smallest perimeter rectangle with all four sides enclosed is in the shape of a square again. So very similar to when we had fixed perimeter, right? So fixed perimeter maximum area. So it was in the shape of a square, and the same thing when we have a fixed area and we want the minimum perimeter. So in a square, we know that length and width will all be equal to each other. Now the smallest perimeter rectangle with three sides enclosed will be in the shape of a rectangle where the length would equal twice the W. And again, we have the same scenario that we mentioned before. So we drew a picture when we maximize the area, where the length would equal twice the width. The smallest perimeter rectangle with two sides enclosed is in the shape of a square again, where the length equals the width. So again, we are in that similar scenario when we had the corner of a building and we were trying to enclose a parking lot area. And we said that if we only needed to enclose two of the sides, then a square shape would do the trick, okay? Now, the smallest perimeter triangle, again, will be in the shape of an equilateral triangle. Sorry. Triangle. Okay, so let's take a look at a couple of examples where the perimeter is being minimized and the area is fixed. So the first example number 3 says, what are the dimensions of a rectangle with area 36 meters squared and minimum perimeter? So we're given the area of 36 meters squared, and we want to know what the perimeter is, and we want to keep the perimeter minimum. So we're going to say perimeter minimum will be when rectangle is in the shape of a square. So it's a special rectangle, right? Which means length equals width, which means that the area equals length squared, which means that 36 must equal L squared, square root both sides to get the value of L. So length will be 6 meters. Length and width are the same. So we're going to say perimeter is equal to 4 lengths or 4 widths, same idea. So that would be 4 times 6 or 24 meters. So we need at least 24 meters to enclose a rectangular shape area of 36 meters squared.